are what you are covering. Some of them are kind of bordering or on intermediate to advanced, so we'll get to those answers after the webinar. One question that keeps coming up is what are the double lines that are connecting your batteries?
Yes, that's a good question. By default, they don't exist because fancy wires is, I think, switched off by default. So you might as well see this single lines. However, the wires can be used if you switch on this option, draw fancy wires. It will tell you something about the kind of data that flows through this wire. I can just show this in a brand new file. So if I have a point here, an empty point parameter, and I share it, there is no data going from left to right because this one is empty, so there's no data flowing through this wire, and the wire will be orange. And if there's one point, then we have a single gray line because there's one piece of data flowing from left to right. If I go in here and pick multiple points instead, then we have a double line, which means we have to not just one piece of data, but a list of data flowing from left to right, in this case 21 points. The dashed lines which you saw in this example indicate that it's not just multiple points, but it's actually multiple lists of points. So if I open up the tooltip for the P output, you will see that there's a total of 1,681 points, but they are stored into small lists of 41 points each. So this double line, dashed double line, indicates that there is not just one list, but multiple lists going from left to right. And due to the nature of this component, it outputs lists of lists, and therefore all the lines are double, except for this one here, which only has a single value, which is therefore a single line. Normally, you use a tooltips to see the data inside a parameter. You could also use text panels, which is the yellow icon here with this little squiggle on it, to attach it to an output, and it actually shows you your data, how it's laid out. But the wires are sort of a shortcut, visual shortcut to see what's going on here.
Great.
Okay, I'd like to go a bit further here. We have circles which are the maximum size, and we have circles which are so small that they actually have no radius. They have a 0 radius because the pixel here was completely black. It actually means we have quite a few circles in this list which are invalid. So if I look at this data, we have an invalid circle in the entire first column of the grid. And there's a lot of invalid circles. And only when the pixel is not completely gray or black do we get a valid circle which has a small radius, such as a very, very small radius here. So what I'd like to do is take all these circles and remove the ones that have a very small radius, because we can't manufacture things with a certain below a certain size. So I want to take these circles and compare the radius to a preset value, and if that radius is smaller than a constant, we'll remove the circle from the list. Now, the way we'll do this is using a cull pattern component. We use the verb culling in Grasshopper to indicate that we remove data from a list of data, and you will find culling in the Sets tab. There's Sets, Sequence panel. There are 3 cull components and a random cull component called random reduce. So we can cull specific objects by index. We can cull every second object or every fourth object out of a list. And we can cull objects using a pattern of Boolean true-false values. And we'll use the cull pattern to actually remove unwanted circles. So I'll make a new cull pattern component. This thing takes a list of data, any data. It could be circles, it could be points, it could be numbers, it doesn't matter. And it takes a culling pattern. And there's actually a default pattern here set to false, false, true, true. Now this means that the first 2 values are removed, false, false, and then the next two are maintained, true, true. So if I hide my circles, preview off, and share them with the list, what we get is this false, false, true, true pattern repeated over and over again in this list of data. So false, false, destroy, destroy, true, true, keep, keep. But we don't want to have a small pattern that repeats. We want to have a large pattern that actually is the same size as our collection of data, because we want to be able to specify for every individual circle whether it can stay or whether it has to go. So we need to actually generate a calling pattern, which is a pattern of true and false values, where it shall be false if the radius is small and true if the radius is big. So we can compare a radius to a constant value using a larger than comparison. If I search for larger, you have a larger than component. We can compare a radius to a constant value, and I'll use a slider again. And this time I will, well, it's fine. And this thing actually compares the radius to this constant value and tells me if it's smaller or larger than that constant. And since my constant is 0.5 and my radius is at most 0.25, they're all smaller than the constant. But as I move this thing down, at some point we should start seeing, there we are, true values in this list, as more and more circles are now bigger than our limit. Okay. Since we have these true false values, I can just put those in and overwrite the default pattern. And now we have a custom-made pattern which can be used and to remove bigger and bigger circles from this entire list. So now we only allow for the biggest ones, and now we allow for smaller and smaller circles to remain in this collection. So if your drilling size is at least 0.08, you can actually make sure that you don't generate details smaller than that size. Culling is a very, very important skill to have, because you often have data which consists of both valid and invalid data. And the most common way to remove that is to use some form of evaluation, such as larger than or smaller than, and then a culling pattern to remove the unwanted pieces of data. There's one more thing which I'd like to show you, which is that this actually is not just real-time within Grasshopper, but also within Windows. This image here exists on the disk, right? It's an actual image file in this location here, PNG file. Now, when that file changes, the change is seen in Grasshopper and immediately updated. So I can start PaintShop Pro, for example, and open that file and actually change it. And we should see the pattern here change as we save the image out. So let me just size it back to a small size. We'll open the image in PaintShop Pro. We'll show it around a viewport on the right, and I will start painting. That's black and blue apparently. And when I save this image in 3, 2, 1, you can see the immediate update in the viewport here as those changes made it all the way down to Grasshopper and then eventually all the way down to Rhino. So again, save in 3, 2, 1, instant update. If you don't want this to happen, which is of course possible, you can just open up the image sampler and switch off the auto-update feature, and then it'll actually stop responding to changes to the file. Yes, one more thing. Since we're sampling brightness, the preview here doesn't show the blueness because blue is not a part of brightness. So if we were to sample, say, the green channel, it would show only the green channel in the preview. And if we sample the saturation, again, it would be something else. That's actually a bit, okay. A shark, yes. So this image shows you the actual data that's being sampled. It doesn't show you the image unless you pick color sampling, which of course goes haywire because it doesn't like using colors for radius. Let's go back to brightness. Okay. So I'll move on to the next example if there are no questions, but there are questions. Okay.
We have about 5, David. One has to do with the slider bar. Can you animate the slider bar?
Yes, you can. If I change this one, it changes the size of the circles. So we can animate this slider here and have it run from the first value to the last value and save the images out for every frame. So you can just open a menu and pick on the animate item, which will open up the animation editor. You get a preview from your viewport, what's actually shown. You can specify the sizes of the animation, which viewport to animate. And you can even add little tags at the bottom here, where you have things like the value, which you can add to the image itself. So as the slider moves from 0 to 1, that number can be embedded into the image itself. Well, I can actually do this. I mean, it's not difficult, but it just press OK and it'll actually work. And this will generate a bunch of images. It will not generate a video file. So you will then have to go in and actually compile the image, the video using some other software. If you don't want PNG or you can just switch it to BMP or JPEG and it'll actually save the different file formats right there. Okay. Next example.
Okay. Next question. Could you?
Sorry,
That's
sorry.
okay. Could you review how you got the options for getting the picture in to Rhino? And I've got 2 more questions after this.
There's 2 ways in which you can actually import an image file into Grasshopper. The first one is just to drag and drop from Explorer directly into Grasshopper. So you take an image, you drag it from Explorer, and when you drag it over Grasshopper, screen updates, and you can just drop it here and it'll actually generate a new image sampler which points to that file. The other way is to make a new image sampler from the menu, the toolbar, sorry, which will be blank by default because it doesn't have an image yet. And then you can open it up by double-clicking it and actually picking a file from this box here. So you can either paste in the file path or actually navigate towards an image. And now it's referenced.
Okay. And next, could you explain how to save Grasshopper data and baking?
Okay. Saving Grasshopper files is through the Grasshopper menu, so I just do File Save, and that's the same as all Windows applications. But baking is interesting because this geometry doesn't actually exist. It's drawn on the screen. You can select it. You can't render it. You can export it. You can't mill it. It doesn't really exist as far as Rhino is concerned. So we have to actually turn this red data into real Rhino curves before we can use it. And this is called baking process. So you select the data you want to bake. In this case, it's our circles here. And you can click on the Bake Selected Objects toolbar menu item, which is the fried egg icon. So when I do that, it actually generates all the circles. I can close Grasshopper, and I'm left with circles in Rhino, which can be selected, exported, used in other commands. But these things don't update. So if I change my definition, these circles will remain fixed. So if I change my Grasshopper file, you can now see that there's actually the new circles in green and the old circles which haven't updated in black, which are still there. And at present, there is no way to smart bake, as it were. But there are plenty of plugins which offer extra baking functionality. So you actually get free plugins for Grasshopper, which allow you to bake stuff on the fly, or which allow you to assign proper layers and proper colors or proper names as you bake stuff from a document here. So if that is something that's useful for you. Please do check that out. Okay.